My name is Jay Sugarman, and I want to welcome you to Innovation Showcase. The main purpose of this ongoing series is to inform viewers about exciting innovations and creative individuals across the fields of business, science, technology, education, and the arts. Today, via Zoom, we're fortunate to have as our guest Dr. Leighton Davies-Smith. Leighton is a leading authority on the function of writing instruments, inks, and ink delivery systems. He's worked on a number of leading global pen brands, is a named inventor on dozens of granted and pending patents, and a highly sought-after technical consultant today. Let's start by meeting Leighton and then finding out how he goes about creating and designing a wide range of writing instruments and inks, not to mention a newly released teeth whitening pen. Welcome. Delighted to be able to be here.
Hi, Jay. Very pleased to be here myself.
I'm very eager to hear and have you inform viewers about some of your many accomplishments and current endeavors. But before we jump right to that, I think it would be of interest if you briefly share a little bit about your background and how you became interested in designing writing instruments and inks.
Sure. Well, actually, my PhD is in electrochemistry, corrosion chemistry specifically, even more specifically, seawater corrosion. And so my first job actually out of college was actually working for Duracell batteries. And that would make sense as an electrochemist. And I was with them for about 3 years, I think it was. And then I realized that maybe that wasn't for me. And so I applied for a job at Parker Pen as a materials scientist, because I was very much more focused on less on academic activities and very much more on materials, and actually spent a lot of time bobbing around on boats when I was doing my PhD research in seawater corrosion. But unfortunately, they'd already accepted another person for the material scientist job, and so they offered me the opportunity to interview for an ink chemist's job. And I was a little mercenary back in those days, and I said, "Well, how much does that role pay?" And it was attractive to me, so I said, "Well, I can learn about ink chemistry." At that point, I knew nothing about ink chemistry, so I was able to spend a bit of time with a retired ink chemist that lived relatively locally, and learned a tremendous amount from him. And then as I was getting more into ink formulation activity, I also then started to learn about the engineering aspects of writing instruments. And that I found interesting. I'm not a formally educated engineer, but I've learned a tremendous amount from all the engineers that I've worked with in my career. And then I really liked the fact that I was working on something that everybody would have an opinion about. Everybody uses pens. And I often hear all the complaints about pens that I've even developed myself, as well as all the praise. So it's actually quite nice to be able to understand that people have an interest, even with something that's as mundane as a writing instrument. We all take them for granted, and there's a tremendous amount of technology that actually goes into them, not just the ink formulation side. That's certainly an important part, but all the engineering aspects of how you move the liquid from one place to another in a very controlled way. And so I still find it fascinating today. And while you mentioned earlier about a teeth whitening pen, the reality is that many of the aspects of both writing instruments and those types of cosmetic pens are very, very similar in many respects, really. And so I'm still fascinated today. And again, teeth whitening pens, people have opinions about those as well.
That's terrific. Well, hope to hear maybe a little bit more a little later. Would you continue by sharing a little bit, how do you go about envisioning and then creating, say, a writing instrument? What's some of the process, the steps that you go through?
Well, for me, my focus is rarely on the aesthetics of the pen. So not so much how it looks, not so much the materials that the product is manufactured from, unless they have an impact on ergonomics. or some other functional benefit. So my focus has always been on the engine of the pen, if you like. So it's the writing system. So it's the development of the ink and how that interacts with some of the mechanical moving parts, some of the stationary parts. There is a bit of corrosion avoidance in there as well, because some inks can be quite corrosive to some of the materials that are used in the construction of pens. So, and you have to look at the whole thing holistically. So you can't just develop an ink and you can't just develop a writing tip. You've got to be able to develop them in a way where they work actually very well together. And so they can't be developed too much in isolation. You've got to start somewhere, of course. But once you start to get a mark on paper, then it's a question of how can you improve that for the end user, either through ergonomic design or through ink formulation modification or some adjustments to the mechanical aspects of the writing tips and so on, or the feeders. So that's the approach that I've always had. Start with a mark on the paper and then build off from there with the intent of making sure that everything is working harmoniously together.
How many prototypes might you go through before you have a finished product that eventually makes its way to market?
Sometimes dozens, sometimes even more than that. It's rare that you hit the nail on the head immediately. There's always something that you have to consider. And with these products, you also have to think about their lifespan. And so that when you have a pen in your desk drawer, even though it's been in your desk drawer for maybe 3 or 4 years, you still will get frustrated if you pull that pen out and it's not writing as well as you remember it did. Hopefully you're using pens more frequently than that. But the reality is that we try and design the products not just for here and now, but also for longer down the line. So yes, we design them with a certain writing life. So that's dictated by the ink flow characteristics. It's also dictated by how much ink you're able to physically contain within the reservoir. And so a lot of consumers want to maximize the writing life. They want the pen to last a long time, and they want it to behave exactly the same at the end of the life of the product, when you're just about to run out of ink, as it did when you first bought it. And so all of those elements you have to take into consideration to develop a very stable and consistent writing instrument that has a certain lifespan.
We're fortunate to have some images of some of the tools you use in your craft. And first one we have here is the write testing machine. Can you share a little bit about how this informs your practice?
Sure. This is the workhorse of anyone involved in writing instrument development. So many companies that I've worked for and with can have dozens of these machines, either for quality control or, in my case, for development purposes. So the way this works, there's a roll of paper which you can't see. It's actually contained within the body of the blue section, the base of the write test machine. And you can see on the top there that we have spaces for 10 writing instruments to be positioned above that paper. And the way that this particular machine works is that we can load up those 10 stations with whatever writing instrument we've developed. Maybe it's a prototype, or maybe it's a finished product that the quality control team is looking to check before the product is dispatched. But for me, it was all about trying to understand how our prototypes were working. And there's no handwriting involved in this. This is purely mechanical, with the intent of trying to understand how the ink is being transferred from the refill, from the pen, onto the paper. So we can change the paper type, and you can see that these 10 stations are actually moving in a spiral circular manner all at once, all 10 at the same time. And so what you're able to do, if you weigh each of those 10 prototypes before you even start a test, and then you weigh them after a certain written distance, because there's a little clock in the bottom right-hand corner, and that's clicking over the number of meters that the pen is writing for. What you're able then to do periodically through the life of the product, as you write out all of the ink, you're able to assess how much ink is being transferred from the refill onto the paper. And so that we call that laydown. So how much is the ink laydown, and how much, importantly, does it change from the start of the life of the product right through to the end of the life of the product?
Nice.
So we can also determine how clean the writing is. And how clean it is under certain circumstances of writing style. So in the top right-hand corner there, you see some variables that we're able to control on this machine. So we can change the writing speed. We can change the writing angle. Some people have a lower writing angle than a high one. We can also, on top of each of those 10 refill stations, we can add weights. So that changes the writing load. Paper type we've already talked about, even pen rotation. You know, when every time you click a push button pen, there's a very good chance that the refill is actually rotating with each click. So every time you use it, you're writing on a different part of the writing tip itself. So this gives us a very good understanding as to how a writing system prototype is actually functionally depositing the ink. How well is it doing?
Nice, nice. What's the role, moving on to some other equipment, of high magnification in assessing the ink and perhaps the flow and the whole system?
Yeah, so we have 3 images here. We'll start with the ball pen. That write test machine that we were just been talking about, that is one example of a machine for doing this type of test. But there is another one. That first one, actually, the pens are moving. All 10 are moving at the same time, and the paper is stationary. When I created these images that you'll see on this particular slide, the pen was stationary and the paper was moving. So what I'm able to do then is use a magnifier to look at what's happening right at the ball to paper interface. And you can understand by looking at these images, and in fact videos that you can create, because now the paper is moving but the pen is staying fixed, we can see how the ink is being transferred to the paper under certain conditions: high writing angle, low writing angle, high writing speed, low writing speed. And when you start to look at how the ink and the writing tip itself interact with each other, it can give you some indication as to what it is that you might need to modify in order to make a better solution. So that ball pen that you see on the far left, personally, I don't like writing with ball pens. And part of the reason is what you see right there. There's a buildup of ink that can sometimes occur. We try and design that out either through the ink formulation or through the design of the tip. So that happens minimally at best, and hopefully never, I guess, when you're writing. But you can also see that the ball diameter here, I think this is a 1 millimeter ball, so you can see how magnified this is. Not all of the ink from the ball actually gets transferred to the paper. You can see it's a very narrow line width. So that excess ink has to go back inside the ball chamber area, and it needs to do that cleanly. In this particular instance, it does not. It actually gets scraped off by the non-moving part of the writing tip. And that's what we call then goop, or it's a buildup of a blob, if you like, that can sometimes then get onto your hands and your fingers and onto the writing substrate that you're interacting with. But you take a roller ball, on the other hand, and it's quite a different way of transferring ink to the paper. And you can see the line width, even though the ball size here is smaller than the one on the left, the line width is considerably broader. And that's because essentially you're dragging a puddle of water-based ink around. You can hardly see the ball rotating. There is no sort of print transfer of ink from the ball to the paper surface when you're talking about a rollerball. And then the last one is a gel product. And that's a little bit of combination of the two. It's got some characteristics of rollerball. It's got some characteristics of ball pen.
And moving on, we are going to see some close-ups here.
Yes, obviously most people only see the very tip of a writing tip. They don't get to see what's going on inside. And what goes on inside really is an engineering marvel in my mind. And I can say that as a non-engineer. I'm astonished when I see some of these tips being produced the way that they are and the speed that they are. They're actually produced from a solid block of metal, and they're machined and formed and drilled to create the writing tips that you see on the end of your pen. Oftentimes, the only moving part, the separate component, is the ball. And that gets placed into its ball socket, which you can see on the far left of the left-hand picture. And it sits in there, it sits on a seat, and it's actually retained by spinning the material around the end that forms the rim around the ball to hold it in place. But if you pop the ball out, you see you can see the rim right there. And inside, behind that ball in the previous image, you'll see that there are ink grooves. And that's how the ink gets to the ball surface. So the bottom image on the right-hand side has had the ball removed, and you'll find 5 or 6 ink grooves that are punched into the metal seat. So that material, those slots that you see are removed, and the ball is just placed on that seat. And now the ball has to get well lubricated by the ink in order that that seat doesn't wear, because that seat, if it wears, will have a significant impact on the writing characteristics of the product. And we even changed the ball diameters, finishes. So these are scanning electron microscope images of a very smooth ball surface on the right-hand side that'll give extra smooth writing, and a rougher ball on the left-hand side, which will still be smooth, but not as smooth as the one on the right. But also you need to have some traction. It's almost like a tire on a wheel of a car. You need to have some tread in order for that tire to grip the road surface. So sometimes if you have a ball that's too smooth and slippery, you'll get some slippage as you write over the page of a piece of paper.
Nice, nice. And what is this informing us?
Yep. So this is, again, a scanning electron microscope image of a writing tip in plan view. And those ink grooves that I mentioned earlier are now full of material. And that material is also in the rim between the ball and the housing of the writing tip. Now, this material, we can try and identify where that's come from, and it makes for a poorly designed writing tip. And we can actually get material that's actually clogging not only the rim around the ball, but also the ink grooves that feed the ball chamber. And sometimes this is a self-propelling activity that goes on, because you'll get a little bit of material that gets inside the writing tip via the rim. It starts to block the ink channels. You can't get as much lubricating ink in. That makes the situation worse at the rim. And so it just goes on in cycles after that, until the point is the product just dies. So we're able, in this scanning electron microscope setup, and I rent time on some of these instruments. I don't have one in my garage. So I have in my consulting business, I've rented time at academic institutions to do this type of analysis. But the little graph on the right-hand side allows me to do an elemental analysis of what this extra material is that's inside the writing tip. And that helps me then do a little bit of diagnostic work to try and understand what's the issue with the writing tip, what's the issue with the ink, what's the issue maybe even with the substrate that you're writing on, and how does that inform a change to either one or other of those elements.
It's fascinating here you explain this whole process, because as you mentioned at the beginning, something as common as pen, who thinks at all about how it works or what goes into the design and the whole writing system between the physical part of the pen and then the ink and the delivery system. Really fascinating to hear about. Just a quick word, because another aspect that you're involved with is not only designing, but then patenting some of your work, the work of you and your colleagues. A little bit that's involved with that aspect.
Yes, so this particular pen is one of my designs that I had patented. So this wasn't when I was working for any of my prior employers, where we have some others that we can share in just a moment. But this one, this actually uses magnets. And what I found really quite interesting about magnetic attraction was everybody's done that when it comes to how you want to join two parts together. But I wanted to do something a little differently. So I wanted to use magnetic repulsion. And I wanted to use magnetic repulsion in a way that forced a mechanical movement of another part. So, you know, when you bring two magnets together and you have like poles facing each other, there's a push of one away from the other, that repulsion force. Well, what if you had a system where that repulsive force could actually actuate something? And so I've got an example of this particular product, which hasn't been commercialized, but the image on the right-hand side shows, a badge that everybody normally has to access an office building or a hospital ward or whatever it might be. And I wanted to design a pen that could be attached to the product like this, to the badge. And then I wanted to be able to remove the pen. And in the action of removing the pen, I wanted the tip to come out. So I didn't have to press a button. I didn't have to twist anything in order for the tip to come out of the product. All I would do is just remove it from its magnetic base. And in doing that, I was able to use the repulsive forces when they come back together again to actually force an actuator movement inside the pen itself. So it's a different way of interacting with the pen. And I thought it was quite interesting. I love the idea of having these elements that are a little different, because you can certainly find a lot of other patents where there's attractive forces to bring a cap together with a barrel. But here I wanted to do something quite different and flip it in reverse, if you like.
Brilliant, brilliant. And just a few comments about what we're seeing here.
Yeah, so I can show you in this little model. I'm not sure whether you'll see it very clearly, but here are two parts. And there are magnets in one side, and there are also some magnets in the other. And the intent was that same idea, that we would have some mechanical movement as a consequence of repulsive forces. So when I push this on like that, you wouldn't be able to see it, but there was an immediate turn from that repulsive force. And now that those two parts are locked together, because that rotation force has now mechanically engaged a mechanical lock. And so I can feel it as I try and twist it. I can feel the repulsion, and that actually pushes the parts apart from one another. And so when I put it back on, it's a very quick locked product. So again, it's using magnets in a different way in order to drive a change elsewhere. Here it's a mechanical lock. And you might say, well, why? Well, the intent is, if you've ever used some of the higher end fine writing instruments, they're often threaded caps. And sometimes those threads require 3 or 4 hand turns in order to get the cap off. I don't know about you, but sometimes I've lost my thought by the time I've done that. So the intent really was behind trying to using this was to try and actually get the cap off faster and put it back on faster. So this is, I don't know, a quarter of a turn or something like that, and the cap is off. That's the intent behind it.
Very useful, very useful. And just a quick word about this patent that you received.
Yeah, so this is going back a little ways, but I think it's a fun one, because I use the same thought pattern. Now, this is an ink, and I use the same thought pattern as I've just described with magnetic repulsion and attraction. Here, the quick brown fox jumps over the lazy dog, or whatever it is, in the top 3 lines that of handwriting there. If I wanted to highlight a word, then I would have a traditional yellow-green highlighter. We all know what they look like and how they're used, and that would highlight a certain word. But with Vincent, a colleague of mine at the time, we developed an ink where we actually combined both dyes and pigments into the ink. Now, a little word about dyes and pigments. Pigments are discrete particles of color that are typically not adversely affected by chemical interaction. So what I mean by that, if you take a dye-based ink, which is a solution of color, then I can use some bleaching agents, for example, and I can bleach the color using that bleach. And in Europe, at least, they use this for fountain pen school writers, where they might need to make a correction on what they've written. And the blue dye that's actually used in a fountain pen ink is very, very reactive to a very mild bleach solution. And it can discolor very easily. It can go from blue to colorless in a second. And so that's a good correction tool when you're learning to write with a fountain pen. However, what we decided to do was we would actually combine a red pigment, which is not affected by these chemical bleaching elements, and dyes together in the same ink, which are affected. So all I did here was, and we made an inkjet version of the ink as well, which is the right-hand side, top and bottom. It's printed in black, But in that black formulation, we've got a couple of blue dyes and we have a red pigment, which when we blended them together produces black. But when I now use my bleaching agent and I remove the dye component, I am left with the red pigment that is unaffected by it. And so it's a different way of highlighting, where all I'm doing is actually changing color of the actual text itself and not sort of literally covering the whole word with a bright yellow highlighter ink. So that's what I show in the bottom left there with a quick brown fox. All I did was take this eradicator, we call it, and I eradicated the two dyes that are susceptible. And all I was left with then was the red pigment.
Fascinating, fascinating. You know, as we come to the end of the program, I'd like to hear about some of your current work through your consulting and the different fields that you offer your advice and expertise.
Yeah, so right now, this is not my full-time activity. I enjoy pens and have done for many decades, and so it's a hobby of mine. So the consulting piece is still a hobby of mine that I get to pick up on weekends and my spare time. Not that I have very much right now, as I have another full-time role. However, the vast majority of people who reach out to me are interested either in pen function diagnostics. What's gone wrong with my pen? And I'm not talking on an individual level, although I do get that from time to time. It's more companies that are making pens, and they've identified a tip that they've sourced from one company, and they've identified an ink that they've sourced from another. And then they have an assembly machine, they bring them together, but the pen doesn't work very well. It might make a mark on paper, but it's really not a good writing instrument. And so they often ask me if I can come in and help identify where the problem is, and then identify potential solutions, which might mean modifying the writing tip or the ink, or both. Or it may actually be impacted by the way in which those two components are actually brought together as a system, so the manufacturing process. So when I was doing this full-time, that's where I spent most of my time traveling to clients around the world where they were trying to make a better writing instrument, or even a new one. And that's where the new product development comes in. They didn't know how to go about doing it. And so I would educate them, I would train them, and then ultimately help them walk them through how you make a good writing instrument. So that's what I did in the past, and that's what I do just part-time now.
Terrific, terrific. In just a minute or so, could you summarize what was involved in how the teeth whitening pen works and that viewers and others can look forward to seeing on the market?
Sure. Well, it's already on the market, and it's doing pretty well. And it's a similar setup to a writing instrument in that you have liquid that you want to get from one place to another in a controlled way. But the liquid that's used for teeth whitening is not ink. It's got a lot of challenging elements to it. But in terms of the same approach, they're very, very similar because we have chemical compatibility considerations to take into place. We have controlled liquid delivery, much the same as a pen. This particular pen for teeth whitening is more of an active pen. In other words, you have to click to dispense the formula, whereas writing instruments are fully passive. You don't have to do anything. You just touch the tip to the paper and off the ink goes. So there are differences. And even beyond that, when you're writing with a writing instrument, you're writing on a dry surface. When you're trying to apply a formula to your teeth, you're applying it to a somewhat wetter surface. So, you know, there are similarities, but there are also significant differences as well. But yes, it's great to have been working on teeth whitening pens as well as writing instruments.
Terrific. Well, Leighton, unfortunately, we've come to the end of the program. It's been truly fascinating. Here you give some of the background that goes into the common pen that we give no mind to when we use it, except when it doesn't work for us, right. And then we get quite concerned. But thank you for the background information and continued success with future endeavors.
Thanks very much, Jay. I appreciate having the opportunity to talk to you.
Also want to thank those of you watching for tuning in and hope you'll be able to join us next time.